What if humanity's best hope for survival lies on a planet orbiting our nearest star, and yet we can't even get close? Proxima b might hold all the secrets we're searching for. Other life, new worlds, maybe even a second home. But right now, the distance between us and that planet isn't just huge, it's almost impossible. Why? The answer is stranger than you think. This is not science fiction. This is our universe. Proxima Centauri is the closest star to our Sun, sitting just 4.24 light-years away. A blink of an eye on a cosmic scale, but a vast distance for our current technology. Orbiting this small dim red star is Proxima b, a rocky planet that might have the right conditions to support life. But reaching it is far from simple. So far, humanity has never sent humans beyond the moon, and even our fastest spacecraft take tens of thousands of years to get anywhere near the stars. In this video, we'll explore why traveling to Proxima b is one of the greatest technological and scientific challenges humanity has ever faced. We'll break down the monumental obstacles, the futuristic ideas scientists are developing, and why, spite of everything, reaching this distant world might be crucial for our future survival. Get ready to dive into a journey that stretches our imagination, tests our limits, and asks, what does it really take to reach our closest cosmic neighbor? Proxima b is not just any exoplanet. Discovered in 2016, it orbits within the habitable zone of its star, Proxima Centauri, where temperatures could allow for liquid water, one of the essential ingredients for life as we know it. This potential makes it an extraordinary target for science, as it's our closest chance to find Earth-like conditions beyond the solar system. Scientists are fascinated by Proxima b because it could provide answers to some of humanity's biggest questions. Could life exist elsewhere? What would other worlds look like? And crucially, could this planet one day serve as a new home, if Earth's future became uncertain? However, Proxima Centauri is a red dwarf star, much smaller and cooler than the Sun, with unpredictable flares that could bomb the planet's atmosphere with radiation. This raises questions about Proxima b's true habitability, making exploration more urgent but also more difficult. The prospect of colonizing another world, even just sending probes, ignites the imagination and drives research despite the astronomical challenges. The motivation behind reaching Proxima b is not just curiosity, it's survival, understanding whether humanity's future lies beyond Earth. This scientific and existential importance fuels ambitious projects and innovations. But as we'll see, the vast distance and hostile environment make reaching Proxima b not just a challenge, but a test of human ingenuity on a cosmic scale. The distance to Proxima Centauri b is staggering, around 4.24 light-years, or about 39 trillion kilometers. To put this in perspective, the fastest spacecraft we've ever built wouldn't even reach halfway to Proxima b within a human lifetime. Voyager 1, launched in 1977, and our most distant human-made object, travels at roughly 17 kilometers per second. Even at that incredible speed, it would take about 76,000 years to reach Proxima b. This is where reality hits hard. Traveling to Proxima b with today's technology is simply impossible. Our current rockets burn chemical fuel, perfect for exploring the Moon or Mars, but hopelessly slow for interstellar travel. To reach Proxima b in any reasonable time, we need something radically different. Consider the scale of the problem. Light itself takes more than 4 years to get there. Even if we had a spacecraft traveling at 10% of the speed of light, an enormous speed compared to anything today, the trip would still take 40 years. Far longer than any human mission has ever lasted, and this assumes perfect conditions. Space is not empty. Particles and radiation zip through at high energies, presenting hazards to both spacecraft and any possible crew. We haven't even begun to develop life support systems that could sustain passengers on a decades or centuries-long journey through deep space. Moreover, communication itself is a nightmare. A signal sent from Proxima B would take over 4 years to reach Earth, making real-time conversations impossible. Imagine being truly isolated, with no way to quickly solve emergencies or ask for help. This is why many scientists consider interstellar travel to be a dream for the far future, perhaps centuries or even millennia away. The energy, resources, and technological breakthroughs required are staggering. Yet, that has not stopped ambitious proposals from emerging, ideas that stretch our imagination and challenge the limits of physics. So, how close are we? And what are the technologies that might one day bring Proxima B within reach? We'll explore those next because, as impossible as it seems now, science has a way of surprising us. Traveling to Proxima B demands propulsion technologies far beyond what rockets currently offer. Let's break down the primary options scientists are exploring, their strengths, limits, and why none are simple solutions. First, we have ion and plasma engines. These use electric fields to accelerate ions, offering much greater fuel efficiency than chemical rockets. They are already used in some spacecraft for deep space missions, but their thrust is very low, meaning acceleration is slow. At current rates, it would take tens of thousands of years just to get close to Proxima. So, while efficient, they are too slow for interstellar travel. Next up are nuclear thermal rockets, in which nuclear reactions heat a propellant to produce thrust. These promise higher speeds than chemical rockets and are considered for Mars missions. However, their maximum speeds still fall short by orders of magnitude for Proxima B travel, leaving journey times in the thousands of years. More advanced is the VASIMR engine, a plasma rocket that uses radio waves to ionize and accelerate gas. It could reduce Mars travel time significantly, maybe to months, but even in its most optimistic designs, the trip to Proxima Centauri would still span over 2 millennia. One ambitious idea is nuclear pulse propulsion, like the historic Project Orion concept. This would propel a spacecraft by detonating nuclear bombs behind it. Potentially, a spaceship could reach 5% of light speed, cutting travel time to about 150 years. But it's massively heavy, complex, expensive, and politically controversial, making it a distant possibility. Solar sails use sunlight's pressure to push a spacecraft gently but persistently. Near Earth, this pressure is weak, and reaching interstellar speeds would take millennia. However, paired with powerful Earth-based lasers, sails become a game-changer. This leads us to the most exciting concept: laser or photon sails, the cutting-edge propulsion of the Breakthrough Starshot initiative. This envisions sending tiny, ultra-light spacecraft propelled by focused lasers, powerful enough to accelerate them to 20% of light speed, reaching Proxima in just 20 to 30 years. This requires massive ground-based laser arrays, precise aiming, and ultra-thin sails just nanometers thick. Recent advances in material science have produced ultra-thin, AI-optimized sails with billions of nanoscopic holes that maximize reflectivity and minimize weight. Crucial improvements that could make photonic propulsion viable. Despite its promise, Starshot faces enormous technical hurdles, managing laser power over millions of kilometers, protecting instruments from intense acceleration, and developing workable communication methods. Each technology shows promise but also huge challenges. No one has yet solved how to travel across light years within a human lifetime with current or near-future tech. What lies ahead is a question of physics, engineering, and ambition. a puzzle scientists worldwide are racing to solve. Will we build generation ships that journey for centuries, or will beams of light catapult tiny explorers across the void? The next chapter will show how one real project, Breakthrough Starshot, is turning science fiction into a bold plan for reaching the stars, maybe in this very century. Imagine a mission so ambitious it sounds like science fiction, but it's real, it's happening now. That mission is Breakthrough Starshot, a bold initiative aiming to send tiny spacecraft to Proxima Centauri at speeds up to 20% of the speed of light. The concept is revolutionary. Instead of massive rockets, the plan uses thousands of ultra-lightweight nanocrafts, each weighing just a few grams, equipped with ultra-thin solar sails. These sails would be pushed by lasers powerful enough to accelerate these tiny ships to mind-boggling speeds, making the 4.24 light-year journey in just 2 or 3 decades. How does it work? From Earth, a massive array of ground-based lasers emits a coherent, focused beam, up to 100 gigawatts of power, directly onto the sails. The photons from the laser transfer momentum, pushing the craft forward with incredible acceleration. Once launched, these nanocrafts would cruise silently through interstellar space, uncrewed but loaded with sensors and cameras designed to capture unprecedented data and images of Proxima b and its star system. The goal? To get as close as 1 astronomical unit, roughly the distance from Earth to the Sun, to capture detailed visuals and scientific measurements. Because of their tiny size, the ships face enormous challenges. Communications must be laser-based and highly efficient over light-year distances. The craft must survive collisions with cosmic dust, intense acceleration forces, and decades alone in space. To mitigate risks, the program envisions sending a swarm, thousands of probes simultaneously. If some are lost to collisions or other failures, the mission can still succeed via redundancy. The scientific payoff could be enormous. Images and data from this once unimaginable distance could answer whether Proxima b truly has conditions for life, its atmosphere's composition, magnetic fields, and more. This project isn't just theory. It's led by renowned scientists, backed by billionaires, and builds upon decades of laser and materials research. The first experimental tests, like launching tiny test chips with light sails, have already begun. But major engineering and financial hurdles remain. Building laser arrays powerful and precise enough, miniaturizing instrumentation, and developing deep space communication are ongoing challenges. Still, Breakthrough Starshot represents the closest humanity has come to achieving interstellar travel, marking a historic leap from science fiction to potentially science fact within this century. What could breakthrough science reveal next? The mystery waits among the stars. Exploring Proxima b and reaching for the stars isn't just a technological challenge. It's a profound human journey with scientific, philosophical, and existential significance. Scientifically, a mission to Proxima b promises revolutionary discoveries. Imagine sending probes, or someday humans, to a new world to study its atmosphere, geology, and potential signs of life up close. These insights could answer questions we've long pondered. How common is life in the universe? What can the conditions of other planets teach us about our own Earth? Proxima b offers the closest chance to begin answering these mystery-shaping questions. But this mission is more than science. It marks humanity's transformation from a species bound to a single planet into an interstellar civilization. Achieving this leap demands breakthroughs in engineering, societal commitment, and global cooperation on a scale never seen before. It forces us to confront the challenges of sustaining life across decades or even centuries. maintaining hope and purpose through generational voyages. Philosophers and thinkers have often reflected on what interstellar exploration means for our identity. Carl Sagan famously said, "When we're ready to visit other stars, we won't be the same people." Traveling beyond the solar system reshapes our sense of self, from isolated earthbound creatures to explorers woven into the vast cosmic story. Then there's the urgent existential side. Our planet faces growing environmental threats, population pressures, and resource limits. Proxima b, uncertain and remote as it is, represents a potential refuge, a backup plan for humanity's survival. Could life continue elsewhere if Earth becomes uninhabitable? This question pushes us toward bold ambitions. But these hopes come with dilemmas and questions. What if Proxima b is hostile to life? What if extraterrestrial life already exists there? How do we responsibly explore without harming unknown ecosystems or seeding Earth microbes? The quest to reach another star challenges our ethics alongside our technology. The drive to explore, breaking boundaries, venturing into the unknown, has always defined humanity. The story of Proxima b is part of that legacy, blending stern scientific rigor with timeless courage and curiosity. As we stand on the cusp of interstellar discovery, we find ourselves facing not just new worlds, but new responsibilities. The journey to Proxima b is a testament to human potential and a call to stewardship of life, on Earth and beyond. So, what secrets does the cosmos still hide? What mysteries await discovery beyond Proxima b? The answers could change everything we thought we knew about life, existence, and our place in the universe. If you're ready to dive deeper into the unknown and explore what could be humanity's next giant leap, don't miss what's coming next. Stay curious, stay wondering, and prepare to see the stars like never before.